Hello everybody, welcome to chapter 6. So this is our first full-length lesson video. We're starting with 6.1 today. Chapter 6 is dealing strictly with polynomials. And in 6.1 we're going to be actually talking about what a polynomial is and the makeup of a polynomial. Now this might not be a new word for some of us. We may have talked about this last year. You may have seen this in 8th grade. For some of us, this might be a brand new word. So today we're going to spend our time talking about what a polynomial is. So we'll start off with a couple definitions. So a polynomial is a mathematical expression containing many terms. The sum of terms of the form ax to the k, where k is a non-negative integer. So there's a few things going on in there that I kind of want to direct our attention to. And the first being is that a polynomial is a mathematical expression containing many terms. Now we're going to see here in a short while that there are different types of polynomials containing different numbers of terms. Now these terms will have the form ax to the k. Okay, ax to the k. Now, we've got that weird variable there, k, which appears to be in the exponent of x, which it is. It is the exponent of x. Now, it is very important that we understand, and this is the make or break for a polynomial, that k has to be a non-negative integer. So, guys, when we talk about non-negative integers, we're talking about the numbers 0, 1, 2, 3, etc. So k can only be a non-negative integer in order for it to be a polynomial. Now, a polynomial is made up of terms, and a term is each product within a polynomial. So, guys, this ax to the k, this is a term. That is a term. And each term has what we call a coefficient, which is the number being multiplied by a variable. So in this case, the a is going to be our coefficient. Oh, kind of squeeze that in there. Now, guys, please remember that a is standing for some number in that term. Okay, we know that the a is not actually going to be there when we look at these polynomials. That could be representative of any number in front of that x in the term. So let's take a look at our first polynomial here. We have m cubed plus 8m squared minus 10m plus 5. And that is a little blurry, so I'll just rewrite that up here. M cubed plus 8m squared minus 10m plus 5. So guys, as we can see, and as it says here, this polynomial has 4 terms. Now, it's actually quite easy to identify the terms because terms are always separated by addition and subtraction. So if we look through our polynomial, we can see, okay, there's an addition here, subtraction, and addition. So more than likely, there's going to be, if there's 3 operations there, there's going to be 4 terms because what those do is they separate each individual term. All right, and if you guys notice, each term is written in the form ax to the k power. Now, we talk about some important terminology here with a polynomial. So the first term is m cubed. Now, guys, that's just the term that's out in front, the leading term, or in this case, the first term, m cubed, or m to the 3rd power. The coefficient on that term, oftentimes called the leading coefficient, is a equals 1. Now remember, guys, there is a coefficient here. Remember, if there's not one visible, there's always a 1 there. There's always a 1 there. Okay, or that invisible 1. So this polynomial is expressed in terms of the variable m. Remember, guys, we can really choose any variable we want. We are more than often not going to see x. In this case, we have an expression in terms of the variable m. And our exponent, our highest exponent in the polynomial is 3. And what we're going to see here in a little bit, guys, is that the highest exponent in the polynomial is what is going to define that polynomial. All right. And the last thing that we want to point out here is this last term down here, this 5. If we notice, guys, the 5 doesn't have an x with it. So you might say, well, I thought that all the terms were in the form ax to the k. Well, guys, and this is kind of jumping ahead a little bit in the chapter, there is an x next to that 5, but that x is raised to the power of 0. So if you guys remember last year, and like I said, this is jumping ahead a little bit in this chapter, x to the 0 power is actually equal to 1. So that's really just 5 times 1, which is 5. So that 5 is called our constant. It's called the constant term in the polynomial because it has no variable, okay, or no visible variable next to it. So guys, these are some terms that we're going to be using throughout the year. Definitely good to know them and to study them. Okay, so for example 1 here, they want us to write each term from the example above and then identify the coefficient and exponent. The first term has already been completed for us. So the first term, if we recall, in that polynomial was m to the third. It had coefficient of 1 because we had that invisible 1 out in front, and its exponent is 3. So then the second one, if we go back, our second term was 8m squared. 8m squared. So that's our full term. 8m squared. Our coefficient is 8. Remember, that's the number in front of the term. And our exponent is 2. Then we move to our third, which now be careful here, guys, because that is not just 10m, it is a negative 10m. We do take the sign in front of the term. So we have negative 10m. Our coefficient is negative 10. And our exponent, remember, guys, if there's not an exponent there, it is 1. Okay, so our exponent in this case is 1. And then finally, our last term is that constant at the end, that positive 5. Now, it is its own coefficient. And we did talk a little bit about this. You might say, well, you know, there's no m. There's no m with the 5. So what is the exponent? Well, guys, it is, in fact, 0. And we can see this pattern, 3, 2, 1, 0. Okay. Okay, let's move on. So, example 2 wants us to analyze each polynomial, identify the terms and coefficients in each. So, if we look at A, we have ourselves a polynomial with 2 terms in it. So our terms in this case are negative 2x squared and 100x. And all we're going to do is we're going to go ahead and identify the coefficients with each of those terms. So the coefficient that goes with negative 2x squared is negative 2. Remember, guys, again, it's just that leading or that number that's out in front of the term. And then for 100x, it's simply 100. Now if we jump over here to B, we have a polynomial with 3 terms in it. And our terms are y squared, negative 4y, don't forget to take that negative, and positive 3. And again, our coefficients for each of these terms. So So for y squared, remember there's that invisible 1 out in front. Negative 4y is going to be negative 4. And then 3 is simply 3. Okay, so let's jump into some more terms here, some more terminology. So these next three terms are going to allow us to identify different polynomials based on the number of terms that are within each polynomial. So as it says here, polynomials are named according to the number of terms that they have. So if we start off with the first term, monomial is a polynomial with only one term. And some of you might recognize the root word here, mono, which does mean one. So that is a polynomial with only one term. So if we move on to binomial, that's a polynomial with exactly two terms. And again, if we look at the root word here, bi, that does signify 2. Continuing with the same pattern here, if we look at trinomial, that's a polynomial with exactly 3 terms. And again, guys, there's a root word there, tri, which does represent 3. Now, there are further ways to identify different types of polynomials. And another way, guys, is through the degree, what we call the degree of the polynomial. All right, and some of you might say, well, degree, is that dealing with temperature? No, it's not dealing with temperature. When you guys think degree, I want you guys to think exponent. Okay, exponent. So let's start off with the term degree of a term. What's the degree of a term? So the degree of a term is the exponent of a term. And remember, guys, a term is in the form ax to the k. So when we're talking about the degree, what we're talking about here, guys, is the k value, or the exponent. That is the degree of a term. Now, the degree of a polynomial is the greatest exponent in a polynomial. So what you guys are going to have to do is, in order to determine the degree of a polynomial, you're going to have to look at all the terms, look at all their degrees, and determine which degree is the largest. And that will be the degree of the polynomial. And we'll take a look at this here in a second when we look at some examples. So they do provide an example for us right here. So they're giving us the polynomial 4x plus 3, which we've seen this year. You guys might recognize that as a linear expression. The greatest exponent in 4x plus 3 is that 1, that exponent of 1 on the x. So we say that the degree of the polynomial 4x plus 3 is 1. And you guys have heard me talk about that earlier this year. We've talked about linear equations and how their highest power is 1. Same thing here, okay? Except we don't have an equation. We simply have an expression, which is a polynomial here, a polynomial. Okay, looking at example 3 here. So Khalid says that 3x to the negative second power plus 4x minus 1 is a polynomial with a degree of 1 because 1 is the greatest exponent, and it is a trinomial because it has 3 terms. Jasmine disagrees and says that this is not a polynomial at all because the power on the first term is not a whole number. Who is correct? Explain your reasoning. So let's rewrite this expression out. So we're just going to call it an expression for right now, guys, because we don't really know if it's a polynomial or not. So we'll just be very general and call it an expression. Now, we do in fact see that it does have it does have 3 terms. Now, just because it has 3 terms doesn't mean it's a polynomial. It could just be an expression with 3 terms. So what we really have to be focusing in on is the discrepancy between Jasmine and Kali in reference to this exponent right here. Now, if you guys recall, if we go all the way back here to the definition of a polynomial, it said where k is a non-negative integer. K is a non-negative integer. So that means any powers that we have on our terms have to be non-negative integers, or as Jasmine stated it, they have to be whole numbers. Guys, -2 is not a whole number. It is an integer, but it's not non-negative. So therefore, Jasmine is actually correct here. Now, if we change that -2 to a +2, then we would have a polynomial. But because of that negative, ladies and gentlemen, this is not a polynomial. So guys, anytime you see a negative power or a fractional power, we're almost always looking at a non-polynomial, because neither of those numbers are whole numbers. And our powers in a polynomial always have to be whole numbers. So if we look down here at example 4, kind of talking about the same concept here, it says describe why each expression is not a polynomial. So if we start off with A here, and so some of these concepts with A and B, guys, we're going to be covering more in depth later in the chapter. However, these are concepts that you should have discussed in 8th grade. So looking at A, we have 4 over x. So we can actually rewrite 4 over x as 4 times x to the negative first. Now, the reasoning behind this, guys, we will discuss later on. In the middle of chapter 6, we'll discuss why we can rewrite it like that. But all we need to know right now is that, okay, so if 4 over x is actually 4x to the negative first, this is not a polynomial because -1 is a negative integer. And remember, guys, we cannot have negative integer values for powers in our polynomial. So 4 over x, not a polynomial. So let's move over here to the square root of x. So some of you might look at the square root of x and say, well, that doesn't really have a power on it. Square root of x can actually be written as x to a power. So this is another concept that we're going to talk about later on in this chapter. But the square root of x can be rewritten as x to the 1/2 power. Again, if we direct our attention to the degree, 1/2 is not even an integer. It's not even an integer, let alone a whole number. Remember, 1/2 is what we call a rational number. It is a rational number. Remember, guys, rational numbers are numbers that are written as fractions. So again, the square root of x, which can be written as x to the 1/2, is not a polynomial. Why is it not a polynomial? Because 1/2 is not an integer. It's not an integer. So guys, the dead giveaways on these are going to be the negative exponents and the fractional exponents. As soon as you see those, you will automatically know that the expression is not a polynomial. So moving on to another term here, we have a new definition for standard form. Very, very important. You guys are going to hear me talk about standard form a lot this year. So standard form is a polynomial whose terms are written in descending order, starting with the term with the greatest degree. So guys, remember, descending order means from largest to smallest. I'm always going to ask you guys to try and write polynomials in what we call this standard form. That's mostly how you'll see them written and how I want you to write them. We want to write them from highest power to lowest power. So let's take a look at what that looks like. So if we go down here to example 5. Example 5 says, identify which polynomials are not written in standard form and rewrite them, then determine the degree of the polynomial. So if we take a look at this first polynomial, we have 3n plus n squared. So guys, we know this is a polynomial because we have powers of 1 and 2, both of which are whole numbers. Now, this is not written in standard form because our largest power is not written first. So all we're going to do here, guys, is we're going to rearrange the terms so that the highest power is first. Now, remember, when we rearrange terms in an expression or an equation, the signs follow the terms. Now, in this case, it's not a big deal because both terms are positive. So all I'm going to do is just go ahead and switch them around. And now we're going to identify the degree of this polynomial. We call this a degree 2. And I'm actually going to add a little something here. It's not just a degree 2 polynomial. It is that, but we can actually get a little bit more specific. This is a degree 2 binomial. Why is it a binomial? Remember, guys, it's a binomial because it has 2 terms. And it's degree 2 because its highest power is 2. So we call this a degree 2 binomial. So moving over to B, we have 5x cubed plus 9x squared minus 4x plus 6. Now looking here, guys, we can easily tell, we should be able to see that this in fact is in standard form, because if I go ahead and add in that invisible 1 power there, we can see that the powers do go in descending order: 3, 2, 1, and then there's that invisible x to the 0 next to the 6 there. So this polynomial is actually already in standard form. Now, what's the degree of this polynomial? Well, again, guys, it's the highest power located in the polynomial. So this is degree 3. Now, we do have 4 terms here, and we didn't actually have a name for a polynomial with 4 terms, and we're not going to. What we're going to do instead is we're going to call this a degree 3 4-term polynomial. So any polynomial, guys, over 3 terms, we don't have a name for them. We're just going to name them by the number of terms they have. So a 4-term polynomial, a 5-term polynomial, etc., etc. We won't really be dealing with anything over 4 terms. So you guys should be good with a 4-term polynomial. So we have a monomial, 1 term, a binomial, 2 terms, a trinomial, 3 terms, and then a 4-term polynomial. So let's go ahead and look at C here. So C, we have z squared minus 7z to the 4th minus 3. Now, hopefully by now we can very quickly tell that this is not written in standard form, because that degree 4, which is the highest degree in the polynomial, is not at the front. It's in the middle. So we're going to rearrange these so that we go from highest power to lowest power. Now, guys, I need to move that negative 7z to the 4th to the front. Now, be careful, because remember, that negative is going to follow that term. It's going to follow that term. So I'm going to start with negative 7, z to the fourth. Then I know that degree 2, that's going to be my second highest power, and that's a positive z squared. So plus z squared, and then all I have left is my constant, minus 3. And now I'm in standard form. Negative 7z to the fourth plus z squared minus 3. And we're going to go ahead and name this polynomial. So this is a degree 4 because the highest power is 4. And there are 1, 2, 3 terms. So this is a degree 4 trinomial. A degree 4 trinomial. And remember, guys, the easy way to identify the terms is to usually just count the number of operations. So we have a plus and a minus there. We're not really going to count that negative out in front. That's not really an operation going on. That's signifying that 7z to the fourth is negative. So if you guys really look at the interior operations, 1, 2 of them, so there must be 1, 2, 3 terms. So we have a degree 4 trinomial. All right, guys. Well, that's going to conclude 6.1. We got a lot of new terms in this unit. I will expect you guys to utilize these terms, use these terms in class, and know when I use these terms what they mean. All right, so it's a good idea to familiarize yourself with those terms and make sure that you study them throughout the unit. I hope this was helpful, guys. I'll see you tomorrow.